Perfect, guys. Can you please give me a quick confirmation, right? Sorry for the inconvenience. I'll just wait for 2 minutes. Let all the participants to come. Just for 2 minutes. I hope all of you are clear till over here. Okay, perfect. Thank you, Pragati, for confirming that I am audible. Okay. So, guys, let us start once again, right? So, all of you can listen to me. Can you all please give me a quick confirmation? Guys, can you please give me a quick confirmation? Okay, perfect, guys. Thank you. Thanks a lot. So, guys, as I was, okay, let us start with where we have left. So, actually, the thing is, you have to understand one thing that the test, see this, uh, yes, for the demo part. The test is generally used, guys, the test is generally used for prediction or getting to know the accuracy and training for the calculation. I hope this is clear to everyone. This we have discussed in the previous session. Guys, this we have discussed in the previous session. I hope this is clear to everyone. Can you please give me a quick confirmation with a yes or a no? Perfect. Now, the thing is, since we are doing the prediction from the testing data, right? So I'll be just calling a YPRED. YPRED is nothing but this is a predictor which is based on the testing data, right? Now, what I'll be doing, I'll just show you by visualizing the plot. So as I mentioned in you can say the OneNote, we have to majorly deal with the scatter plot. So I'll just show you the scatter plot that will give you the good visualization. See, you have to understand one thing. This whatever the plot we are just making, we are just using the library matplotlib, right? So I've just called this library .plt. So from that plt, I'm just calling a one of the plots, which is a scatter plot. Now you can see this is giving you the argument x, y, and followed by so many things. Now this subsequent argument is in order to do some more visualization, but I'll just go with a very basic part, which is basically my x. X is my the training x, y is my training y. Since we are doing the visualization on the training set result, you can see out here, right? And followed by one color, right? So these three arguments we will be utilizing, right? So x is my x train, y is my y train. You can skip this one. C stands for the color, right? Or you can also use COLOR, right? So I'll be just using the training set and Y train and the color. I'm just taking the color to be, let's say, red for the visualization. So this is a scatter plot of the training data since we are doing the calculation on the training data, right? I hope this is clear to everyone. All the dots, all the scatter plot will be from the training data, right? Now we will be utilizing another function which is plt.plot. Now this plt.plot is representing the line of best fit. So this is automatically it is doing the ordinary least square method, right? I'll just explain this particular line when I'll just show you the visualization part. So guys, I'll be using again the train. So you can also take it from here. So x train comma, I'll be using the regressor dot predict. See, for the plotting of the training data, we will be, see, this is a testing data in order to predict the accuracy of the testing data. But in order to, you can say know the predicted part, we will be utilizing the training data. I hope all of you are getting this. Can you please give me a quick confirmation, guys? Perfect, perfect, perfect. Now the thing is, for the testing data, we have used the predicted value for the testing data. Over here, I'll be utilizing regressor.predict for the training data. And this time, let me take the color. Let's say, guys, blue. Fine. So I'll be just explaining this line. So I'll be also be utilizing some legends. So legends are basically my salary versus experience data, or you can use anything. So which is based on the type of the data. So plot.title. So I'll be utilizing salary versus experience. So since we are using the, I'll be very specific. So I'll be just writing the training set. Training set. And this is plt dot x label. So X label is for the something which lies on the X axis. So can you tell me like what do we take on onto the X axis, guys? The dependent variable or the independent variable? Guys, can you please tell me like what do we take, the dependent variable or the independent variable on the X label? On the X axis, the independent. So what independent variable we have over here? What independent variable we have over here? Yes, correct. Experience. So let me name this as, let's say, years of experience. And similarly, we will be also be doing it for, you can say, for Y label. So my dependent variable is salary, right? This should be Y. Okay. And plt dot show will visualize the plot. So let us work on visualization part. Okay, I think I haven't called this. Let me call this after this. So you can see it is, there is a beautiful plot which is being constructed. So in this particular plot, you can see the red is showing you the actual salary from the training data. So that's why this color have been highlighted as a red. So this is based on the X train and the Y train. So X train and the Y train. I hope this is clear to everyone, like what dots are showing. This is showing you the actual data. Guys, are we clear with this? Are we clear with the dot part? Okay, perfect. Since, see, you have to remember one thing. This is very important. This particular line, it is a line of best fit, and this is been drawn using the plt.plot module. So this is actually working or fitting the line based on ordinary least square method. So whatever the computation which was involved over here, right? This one, that the sum of the square from the actual to the the predicted one should be the minimum. This particular block of code is doing this particular calculation. So regressor.predict, and color of this trend line is blue, right? I hope this is making sense. Since the calculation is done on the training data, so that's why it has been highlighted as blue. I hope all of you are clear with this, guys. So this is this particular line is being drawn from the second code. Perfect, 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 Suman. Okay, now these things are very clear. Salary versus experience training set. Okay, I have to if I redo it. Okay, now this parentheses have been closed. So this is the title. You can say the X label, which is the years of experience, and the Y label is the salary, and plot.show will show this visualization. So I hope this is clear to everyone. Guys, I hope this is clear to everyone. Okay, perfect, 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 guys. Now the thing is, let's say what I can predict. You can see this line seems to be a very good predictor, because you can see almost half of the data is lying above and half of the data is lying below. And you can see that there are some point which is falling to this line. So while visualizing, you can also figure out that this particular line is definitely a line of best fit. I hope this is clear to everyone, why it is a line of best fit. So this is actually done by using the second line of code. This is doing the ordinary least square method, OLSM. Now I'll be utilizing the same block of code, but I'll be changing some, you can say something on the test set. So I'll just introduce another code just underneath it. I'll just paste the above block of code. Okay. So guys, since we are visualizing the test set result, so can you please tell me what are my test set? How many fields do we have in the test set based on the number of rows? Can you please tell me how many fields do we have on the test set based on the number of rows? There were 30 fields. Test, not the training part. Pragati is not 20. You have to test size is 1 by 3. So 1 by 3 of 30 is 10. Okay, perfect, perfect. So since we are visualizing the test set result, so I'll be just replacing the train with the test. I hope this is clear to everyone. Since we are working on the test set result, so I'll be just replacing the train with the test. And similarly over here. Fine. And guys, are we clear with the first line of code? Guys, are we clear with the first line since we are visualizing the test set result? Guys, can you please give me a quick confirmation that we are clear with the first line? Okay, perfect. You have to be very spontaneous and very active on the chat, because it will show me a connect. Okay, now the thing is, which is very important, plt.plot. This will again populate the line of best fit. But over here, see, this point is very important. You have to mark this as a very important point. This point is very important because the thing is, always remember one thing, that my line of best fit is always based on the training set. Please mark this as a very important point. The line of best fit is always based on the training set. So that's why I haven't written test over here. Instead, I'll be writing the train. So this is the same line what we are just talking about, what we have just utilized over here, right? So this is a very important point, and some of the people will ask you, like, while visualizing the test set result, so what is from where you take the line of best fit, from the training set or from the testing set? So you will take it from the training set. I hope this is clear to everyone, because the calculation we are doing from the training set, and we are applying and we are doing the prediction on the testing set. I hope this is clear to you, clear to everyone, guys. I hope this is clear to everyone. Perfect, guys. Now this time I'll be just changing the color black. Rest everything will remain the same since we are doing it from the test set. Okay. This time I have taken the line of best fit to be black. You can also change the color to any of the things that you want. Any of the visualization that you want, right? So guys, now you can also see that most of the point is lying on the line. So this gives you an idea that this particular line should be the line of best fit, and it follows the ordinary least square method, which is the distance of the blue dot with the black line should be the minimum. The difference of the square of the difference, the sum of the square of the difference of the blue dot with the black line should be the minimum. So this you can also see. And if you want to predict for 11 years and 12 years, what you can do, you can extrapolate the line. I hope this makes sense, guys. Can you please give me a quick confirmation, guys? Okay, perfect, guys. So what we have discussed so far, I'll just have a quick walkthrough. We, from the first three set, we have just utilized the data from the data pre-processing template, as you can see. And after going with the data pre-processing template, we followed the steps which were involved in the simple linear regression. So why these templates are very important, because this will make you efficient and standardized. Let's say if you got some different data, if you know the flow, you just need to simply know how to plug in the values. Let's say what I did over here, it was data.csv. I've just simply replaced it with the file which I'm working with, the salary underscore data.csv. I hope this is making sense. Guys, can you please give me a quick confirmation of a yes and a no? Okay. And all of you know, all of you can also channelize the importance of you can say the template. So I'll be sharing you the simple linear regression template along with the sample underscore data.csv, so that you can practice it on your Google Colab just by the just after the end of the session. I hope this is making sense, guys. So after every class, what you have to do, you have to practice it out, so that whatever the code that we are learning in the class is ingrained in all of you, right? It's it's very handy to all of you. And I'll be also preparing some like Google Drive, in which I'll be sharing you the templates from where you can download and perform it, right? So this will be the thing that we will be doing. So guys, anything that you wanted to ask, please ask. I'll just have a quick walkthrough to like what we have discussed. Are you all clear with what do we mean by ordinary least square method? Guys, okay. And what about splitting the data into the training set and the test set? Can you please tell me the split? How many fields were there in the test set? How many fields were there in the test set? And what about the training set? 20. Perfect. So random state, you can take anything. Let's say all of you knows the importance of the random state. We have discussed in the previous session. Let's say I am working on this data and you are also working on this data. And let's say we have set the random state to be different. So there might be chances that we may end up getting the different result, or the split will be something different of to yours and something different to mine, right? So while working, you take if you are working, let's say 2 or 3 people are working on the same CSV file, so it is recommended that you all three should take the same random state, right? Vaishnavi, it is randomly selecting the data, the training set and the test set. You can take it to be any number, right? It is randomly selecting the data. Okay. Any other query, guys? Please ask. So, guys, can you please tell me like the line of best fit is based on the training set or it is based on the test set? Can you please tell me the line of best fit? Okay, perfect, Pragati. It is based on the training set. So you can see this particular point is very important. I haven't changed the training set, although I'm just visualizing it for the test set, because the line of best fit, the calculation is done with the help of the training set, and the prediction is done based on the test set. I hope this is clear to everyone. Perfect, perfect, perfect. So like this is a very interactive environment, Google Colab. So I'll also show you one more thing. Like let's say if you want to work with this particular file, if you want to save it, so you can also do it. Like okay, I'll just show you one thing. You just simply click on it, save images. So you can directly, let's say if you are working on some project report and it is based on the Python programming. So what you have to show some plotting in your report. So what you can do, you just save images. So it automatically gets stored. And also one more thing, this particular tab will clear the output. So you can see the output has been cleared. Again, I'll just run this. It has been created again. So that's why this is a really very good integrated development environment, which has been created from the Google. And over here, like if you go with Anaconda, you have to install some library. You have to create an environment. But over here, all the libraries are already installed in the cloud server. So what we are just learning right now, we are just doing the computation part on the Google Cloud platform. So I hope this is clear to everyone, like why I'm suggesting or why I'm recommending the Google Colab, because it's a really good integrated development environment. Guys, okay, perfect, perfect. Guys, if you come across any doubt, please ask. I'll be just calling it a day for today. Uh, this was the last demo class. After this, we'll be starting with the regular classes. And I'll also share you the YouTube link so that you can also see the recorded lecture if you come across any doubt. onto the group. So guys, are we clear with this? Okay, it seems that no one of you have any doubt. Everything went perfect. Okay, so let's call it a day, guys, and keep on learning and practice it just after the class. I'm just going to share you this particular notebook. Okay, thank you guys. Happy learning.